Hi everyone, my name is Ravi Prakash and we are discussing divisibility rules and reminders. This is a second class. Okay. So now we'll discuss, right, in the last class we discussed about the divisibility rules of all the numbers of the form 2 raised to n, 5 raised to n. That means all the powers of 2, all the powers of 5, then 3, 9 and 11. Okay. Now we'll discuss some complex ones like 7, 13. Okay. This kind of number 37. Okay. So see, now first funda is actually how to find divisibility rule of a number is 10 raised to which power? Let's say 10 raised to x by any number. 10 raised to x by any number. We are searching for remainder to be plus 1 or minus 1, right? This is the basic funda of divisibility, right? For any number, right? For any number, this is a number, we're dividing it by 10 raised to x and we're searching for remainder to be plus 1 or minus 1, right? Like in previous cases like 3, 9 and 11, it was very easy because 3, 9 and 11 all on dividing by 10 gives remainder of plus 1 or minus 1, so we don't have to put any extra effort there, right? But here in the numbers, like suppose for example I have a new number like 33. The question is, okay, uh a, B, C, D, E, F is a six digit number divided by 33. I have to find remainder, right? Remainder. So now 33 is a new number for me, right? 33 is a new number for me. So how to find the divisibility rule for 33? What we'll do? We'll simply divide 10, we'll search that 33 at what power of 10 will give me a remainder of plus 1 or minus 1. This is what we'll search for. Okay, 33 on dividing by what power of 10 will give me a remainder of plus 1 or minus 1. So if you observe obviously 10 by 33 will not give me remainder of 1 or minus 1. Okay, let's move to 10 square. Let's move to 10 square. So 10 into 10. So 100 by 33 is giving me remainder of plus 1. Yes, 100. Yes, we got it, right? That means 10 square by 33 is giving me a remainder of plus 1. Okay. Now, listen very carefully. Very important concept this is, right? So if 10 square by 33 is giving me a remainder of plus 1, that basically means that every power of 10, every multiple of 10 square on dividing by 33 will give me a remainder of plus 1 only. That means every multiple of 10 square, right? That means 10 raised to 4 by 33. What is the remainder? Same, it is plus 1 only, right? Because 10 square into 10 square by 33. Remainder is plus 1. 1 into 1, 1 only. Right? Similarly, 10 raised to 6 also. Okay. So 10 raised to 4 by 33 is also 1. 10 raised to 6 by 33 is also 1. Like that. So every multiple of 10 square. So I can write here that every multiple, that means every multiple of 10 square, 10 raised to 2k upon 33 will give me a remainder of plus 1. 10 raised to 2k upon 33 will give me a remainder of plus 1, right? Very carefully understand. 10 raised to 2k. Why have I written 10 raised to 2k? Because every multiple of 10 is square. 10 is square or 10 raised to 4 or 10 raised to 6, right? On dividing by 33 will give me remainder of plus 1. Fine. So now if I break this number now, okay, now you see A, B, C, D, E, F is a 6 digit number. If I break this number, how can you write it? A into 10 raised to 4. Sorry, it's a 6 digit number. So 10 raised to 5. 10 raised to 5 plus B into 10 raised to 4 plus C into 10 cube plus D into 10 square plus E into 10 raised to 1 plus F into 10 raised to 0. This divided by, okay, this divided by 33. Now I have to find the divisibility rule or get the remainder. If A, B, C, D, E, F are digits, actual digits 1 to 9 given, so what is the remainder? So for this, see, so why have I done here? 10 raised to 2k by 33 gives me a remainder of plus 1. Gives me a remainder of plus 1. Okay. That means I have to segregate this numerator such as to get a multiple of 10 square. to get a multiple of 10 square, right? I have to segregate such that to get a multiple of 10 square. That means, so how do you get a multiple of 10 square? By picking a group of 2, right? How do you get a multiple of 10 square? By picking a group of 2. See here. From the first two, from the last two, if I start from last two, I'll get nothing as common, right? I can write simply, I get nothing as common, so it is nothing but 10e plus f. So 10e plus f can be written as ef into 10 raised to 0. Nothing can be made a common. Then next two will give me 10. I can take 10 square common here. If I take 10 square common here, what is left here? Left here is 10. If I take 10 square common from these two, so what is left? It is left 10c plus d. What is 10c plus d? A 2-digit number cd. So I can write cd plus. From here, what I can take common? I can take 10 raised to 4 common, right? 10 raised to 4 common into what? If I take 10 raised to 4 common from these two, so 10a plus b is left. What is 10a plus b? Again ab. It's a 2-digit number, right? So this when divided by 33, what is the remainder? This was the question, right? So now you see what have I done? To this form, I have brought to this form. What I wanted, that 33 is a number which on every multiple of 10 square will give me a remainder of plus 1, right? So I have brought it in the form of 10 square, 10 raised to 0, 10 square, 10 raised to 4, right? Now you see, you divide each power of 10 by 33. So 1 by 33, remainder is 1 only. 10 square by 33, remainder is 1 only, right? 10 4 by 33, remainder is 1 only. Because 10 raised to 2k by 33, remainder is 1 only, right? So what is left? What is left here? So we are left with nothing but AB plus CD plus EF. That is the digits in the groups of 2. Digits in the group of 2, right? This is a super important concept. When you divide a number by 33, what I am left with? Digits in the groups of 2. Okay, digits in the groups of 2. Now, let me write here. Right. So I've written here 10 square by 33. 33 was a new number for me. So I've searched at what power of 10 will I get? At what power of 10 dividing by 33 will I get remainder as plus 1 or minus 1? So obviously 10 square by 33, that is 100 by 33 will give me a remainder of plus 1. So 100 by 33 means every multiple of now 10 square will give me remainder of plus 1, because if 10 square by 33 remainder is plus 1, then 10 raised to 4 divided by 33 remainder is also plus 1. That means 10 square, 10 raised to 4, that means every multiple of 10 square, that means 10 raised to 2k. Okay, so 10 raised to 2k divided by 33, remainder is plus 1 only, right? So how to convert this number into form of 10 square? How to convert this number into form of 10 square? We can see here. So we can write like this, and then we can segregate. Since I want in multiples of 10 square, I can segregate in groups of 2, in groups of 2, right? So from last to nothing will come as common. From next to 10 square will come as common. From next to 10 4 will come as common. AB plus CD plus EF is left, right? Now you divide every power of 10 by 33. So 1 by 33, 1. 10 square by 33, 1 is the remainder. 10 4 by 33, 1 is the remainder, right? So what we are left with is AB plus CD plus EF. That's what we were looking for. That's why we found 10 square by 33 remainder is plus 1. Okay. So from the next question onwards, what we can do, see, from the next if you take a number, what we can do is, see, if the question was, suppose, let me rewrite it, A, B, C, D, E, F is a 2-digit number divided by 33, what is the remainder? So what we ultimately got? We ultimately got AB plus CD plus EF. That means in groups of 2. In groups of 2. Why in groups of 2? Because 10 square by 33 will give me a remainder of 1. So 10 square by 33, that means 10 raised to, I can directly write 10 raised to 2k, because if 10 square, that means every multiple of 10 square will give me a remainder of 1 when divided by 33. So 10 raised to 2k form. That's why group of 2. That's why group of 2. Okay. So for example, now if I now I can directly do, right? Don't need to do this much. Directly I can do, if the question is let's say 1, 2, 3, 4, 5, 6 divided by 33. What is the remainder? So first thing we should look for is, okay, 33 is a number on which 10 is square by 33 gives me a remainder of plus 1. That means any number 10 raised to 2, 10, any number, any multiple of 10 is square, that is 10 and 10 raised to 2k form, on dividing by 33 will give me a remainder of plus 1. Okay, that means 10 raised to 2 means make groups of 2, 2. Make groups of 2, 2. Write like this. Okay, right, let me write in next step. Write like this. So now 1, 2, 3, 4. Very important concept we're discussing here. Very important concept. You will not find this in many books. Okay, very important concept. 1, 2, 3, 4, 5, 6 by 33 remainder. So since 33 is at 10 square, 33 at 10 square gives me a remainder of plus 1. So 10 square means for 2 divides in group of 2, 2. Divide in group of 2, 2. And you know mentally why you're doing it, because from the last 2 I'll get nothing as common, so 1 by 33 remainder is plus 1 only. From the next 2, 10 square is common, 10 square by 33 remainder is plus 1 only. From the next 2, 10 raised to 4 is common, 10 raised to 4 by 33 remainder is plus 1 only. Right, so write plus 1 always. Okay, plus 1 means we have to add, take all the, like, treat like all the groups. There are 3 groups of 2 2 here. Since all are plus 1, so add all the groups. So 12 plus 34 plus 56. How much we got? Now there is a number greater than 33. So again you can divide by 33. How much you got? You'll get 102 divide by 33 remainder. Now important step here. Now you can directly do that 33 into 3 is 99. So remainder is 3. That is the answer, correct? But one more thing we can do here is, since it is 102 by 33, and 33, for 33 you can make groups of 2 2. So last we can shorten this big number, any big number, to 2 digits, right? By for 33. If divisor is 33, I can shorten any big number to 2 digits. So here still it is 2 digits, right? So again I can make group of 2 2. So again I can make group of 2 2, right? So let's say here, okay, 102 by 33. So again make a group of 2 2. So this is a group of 2 2. So I can put 0 here to make a group of 2 2. So this is again plus 1. This is again plus 1. Why? Because in first group of 2 nothing will come as common. So 1 by 33 remainder is plus 1 only. From next group of 2, 10 square will come as common. 10 square by 33 remainder is plus 1 only, right? So what is now result of these groups? 0 2 plus 0 1. What is the number? 0 3. So 3 is the answer, right? 3. Didn't we get 3 here? Yes, we got 3. Same answer. So that basically means that always, right, if there is a 100 digit or 3 digit, I can always make a group of 2 2 for 33. Group of 2 2 for 33. Okay, very important thing, 33, right? Okay, now let's discuss some more numbers here. Okay, now we'll discuss this divisibility rule for 7 and 13. Actually both are similar numbers, so 7 and 13 we can write. 7 and 13. See, now again, if a number has to be divided, right, suppose a b c d e f. Okay, so if a b c d e f is again a 6-digit number, I can write like, okay, a into 10 raised to 5 plus b into 10 raised to 4 plus c into 10 cube plus d into 10 square plus e into 10 raised to 1 plus f into 10 raised to 0, right? Now this, when divided by 7, what is the remainder? What is the remainder? This when divided by 7. Now here comes the another punch. How to find divisibility rule for 7, right? So again I told you, right, always any new number I have, any new number, 10 raised to x upon that number should give me a remainder of plus 1 or minus 1. This is what we are searching for always, right? So you see here the number is 7. At which power of 10 it will give me a remainder of plus 1 or minus 1. So 10 into 10, see, 10 by 7 remainder is 3. So obviously it is not plus 1 or minus 1. Then again 10 into 10, 100 by 7. So 100 by 7 remainder is how much? 2. So again it is not plus 1 or minus 1, right? Put one more 10 here. So again now 2 into 10, 20, or so 10 by 7 is 3. So 2 into 3 is 6. So 6 by 7, the remainder is how much? Minus 1. We got, right? 10 into 10 into 10. That means 10 cube by 7. That means 10 cube by 7 will give me 10 cube by 7 will give me a remainder of minus 1. Minus 1. We got this 10 cube, right? But with minus sign, there's an extra responsibility, right? If minus sign comes here, you have an extra responsibility, because unlike previous case where if 10 is square by 33 gives a remainder of plus 1, so every multiple of 10 is square will give me a remainder of plus 1, because plus 1 multiplied n times will be plus 1 only, right? Plus 1 multiplied n times will be plus 1 only. But minus 1, the case is different with minus 1, because minus 1 when multiplied 2 times is plus 1. Minus 1 when multiplied 3 times is minus 1. Right? It is changing, right? So what you can say in this case is, okay, 10 cube by 7 remainder is minus 1. Now next multiple of 10 cube, right? 10 6 by 7. 10 raised to 6 by 7. What is the remainder here? It should be now plus 1. It should be plus 1. Why? Because 10 raised to 6, right? 10 raised to 6 is what? 10 cube into 10 cube. So 10 raised to 6 is nothing but 10 cube into 10 cube. So minus 1 into minus 1 will give me plus 1 here. Plus 1. Then obviously then 10 cube, right? Obviously then 10 raised to 9 by 7 will give me what? Not it will give me minus 1 remainder. 10 raised to 9 by 7 will give me minus 1 as a remainder, right? 10 raised to 9 by 7 will give me minus 1 as a remainder, because now 10 cube for 10 raised to 9, 10 cube multiplied 3 times. So minus 1 minus 1 minus 1 3 times is what? Minus 1. Then 10 raised to 12 by 7. 10 raised to 12 by 7, right? So now it should be plus 1, because for 10 raised to 12, 10 cube multiplied 4 times. So minus 1 minus 1 minus 1 minus 1 4 times is plus 1, right? So like this it goes, right? 10 cube by 7 minus 1, 10 6 by 7 plus 1, 10 9 by 7 minus 1, 10 12 by 7 plus 1, right? So at every multiple of 3, 10 raised to 3k, right? 10 raised to 3k, if I write here, so 10 raised to 3, 10 raised to 6. So every odd power of 10, it is minus 1, and every even power of 10 it is plus 1. Every even power of 10 it is plus 1. Every odd power it is minus 1. Right? That means if at 10 cube I got, that means I need to make groups of how much? I may need to make groups of 3 3. I need to make groups of 3 3. Okay. So let me rub this here, and I need to make groups of 3 3 here. So I'll write here groups of 3 3. So how to make groups of 3 3 here now? You will take 3 3 as a common. Okay. So let me rub it and let me write here that 10 cube by 7 remainder is minus 1, and alternately at odd and even powers of 10, remainder will be minus 1 and plus 1 respectively. That's what we discussed in the previous slide. Okay, respectively. So in that case, if the number is big 1, right, so how to change that number? So you can easily change the number, right? So it's write a big number now. A, B, C, D, E, F, G. Add one more digit. It's a 7-digit number. So you can do it directly now, right? Now for 10 cube, I need groups of 3 3. Right, last one will be left, right? So I need groups of 3 3. Okay. So from first, you can sense it here, right? From last 3, nothing will come as common. What is last 3? G into 10 raised to 0 plus F into 10 raised to 1 plus E into 10 square. Right? So from this 3, nothing will come as common. From next 3, C into 10 cube plus B into 10 is 10 raised to 4 plus sorry, I missed D here, D into 10 cube plus C into 10 raised to 4. Okay, see here, C into 10 raised to 4 plus B into 10 raised to 5 plus A into 10 raised to 6. Okay, this divided by 7. So I want groups of 3, 3. So in this group of 3, and then last one is left, right? So what will come as common here? See, in this group, in the last group, nothing will come as common. Then simply write 10 raised to 6 into A plus. Now, from this 3, 10 cube will come as common. So what is left here is 100B plus 10C plus D. 100B plus 10C plus D is nothing but a 3-digit number BCD. So I can simply write here BCD plus. From next 3, nothing will come as common. So here we can write what? Again 100E plus 10F plus G. So 100E plus 10F plus G is again a 3-digit number EFG. Right, so again EFG I'll write. Now see, its use will become now, because now if we divide this whole number by 7, if I divide this whole number by 7, in this case, divide each power, so 1 by 7, remainder is 1 only. 10 cube by 7, remainder is minus 1. 10 6 by 7, remainder is what? Remainder is plus 1. In this, right? So plus 1, minus 1, plus 1. It goes like this. So see, always last will be always plus 1, because in last nothing comes common. Always last one nothing comes common. So 1 by any number is plus 1, irrespective it is positive or negative, right? Last is always plus 1. Then alternately plus 1, minus 1, plus 1. So had it been 10 raised to 9 here, so again a minus 1. Then 10 raised to 12, again a plus 1. It goes alternately. It goes alternately. Okay. So what is left ultimately here? So we are left with how much? So we are left with, see, A minus BCD plus EFG. So alternately it goes like in groups of 3, 3. In groups of 3, 3, right? There's no group of 3, 3. Again put 2, 0 here, no issue. Right? 0, 0, A is A only. So in groups of 3, 3, alternately positive and negative. So if you got this concept, now you can undo it very quickly, right? Let's say if the question is 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 7, what is the remainder? Now I know that 10 cube by 7 will give me a remainder of minus 1. That means I need to divide in groups of 3, 3. Groups always starting from last, right? Don't count from first, always from last. Okay, groups of 3, 3. Now I know that from first group of 3 nothing will come as common. So 1 by 7 remainder is always plus 1 here. From next 3, 10 cube will come as common. 10 cube will come as common, right? 10 cube by 7 remainder is minus 1. From next 3, 10 raised to 6 will come as common. 10 raised to 6 will come as common. 10 raised to 6 by 7, what is the remainder? 10 raised to 6 by 7. Remainder is what? Remainder is plus 1. So what is the result? Result is 123 plus 789 minus 456 by 7. Now you can solve it easily. This is nothing but 912 minus 456. So 456 by 7. Now I have to do it now manually here, because for 7 the rule was for groups of 3, 3. So already it's shortened to 3 digits now. I can't further shorten it, right? So I have to do it manually. So 7 6 are 42, 3 and 6 36, 7 5 are 35, remainder is 1. So 1 is the answer. So 1 2 3 4 5 6 7 8 9 by 7. What is the remainder? Remainder is 1. So I hope you're getting this concept right. This is a very important concept here. We're discussing, right? 10 cube by 7. So there are rules for 7, rules for 33, rules for 13. All this we can discuss, right? So do watch this video one more time and get all this concept right. Why I'm doing by divide by 7. Why making group of 3, 3. Because 10 cube, if 10 cube by 7 gives me, if 7 on dividing by 10 cube gives me a remainder of minus 1. So what I want, if the number is like this, what I want to arrange such that 10, whatever comes in common, that is in multiple of 10 cube. I want to arrange like that, right? So I'm arranging like that only. So how to get 10 cube as multiple of 10 cube as common? In groups of 3, 3. In last question it was 33. How to get a multiple of, for 33, what it was? 10 is square. So 10 is square by 33 gives me a remainder of plus 1. So for 10 square, how to get multiples of 10 square? In making in groups of 2, 2, like that. Okay. So do watch this video again once again. Okay. I hope you get this concept. Next video will be continuation of this only. Okay. Thank you.